Have you ever noticed that time seems to have a preferred direction? You can watch a movie forward, but backward, it just feels wrong. Take a coffee mug. If you drop it, it shatters. But you'll never see those shards leap off the floor and reassemble themselves. Why not? The laws of motion for individual atoms work perfectly fine in reverse. So why is the big picture so stubborn? The answer lies in the second law of thermodynamics, the rule that defines the arrow of time. At its heart is a concept called entropy. Many people call it disorder, but it's much more profound than just a messy room. Entropy is actually a measurement of probability. It's a way of counting the number of ways a system can be arranged. Think about it this way. There are only a few ways to arrange those shards into a perfect mug. Those are low entropy states. But there are trillions of ways for those shards to be scattered on the floor. Those are high entropy states. Nature doesn't prefer messiness, it just follows the math. High entropy states are simply more likely to happen. This was my great gamble, proving that macroscopic laws are just the result of microscopic statistics. If you open a bottle of perfume, the molecules spread out. They could theoretically all hop back in, but the odds are astronomical. And because systems naturally move toward these more probable high entropy states, time gets its direction. From the burning of a candle to the life of a star, everything is a journey from concentrated energy to dispersed chaos. Heat always flows from hot to cold for the same reason. There are simply more ways for energy to be spread out than bunched up. This means every time we do work, we pay a tax in entropy. Some energy is always lost to the chaos of the universe. As entropy increases, the universe becomes more uniform. The gradients that drive life and motion slowly fade away. On a graph, the line only goes up. This is the only law of physics that explicitly distinguishes the past from the future. Some tried to cheat the law, like James Clerk Maxwell and his famous demon. But the law always wins in the end. Even the demon has to use energy to gather information, and that information itself has an entropy cost. The total entropy of an isolated system never decreases. It is the most ironclad rule in all of science. You might think life violates this. We are highly ordered after all. But we create massive amounts of chaos in the environment to stay that way. We are localized pockets of order, fueled by a relentless increase in the universe's total messiness. The chaos is constant. Every breath, every thought, every heartbeat is a step further along the arrow of time. It can be scary to think that the universe is winding down, but this decay is exactly what makes everything interesting. Without the flow of entropy, there would be no change, no growth, no moments that only happen once. We live in the sweet spot, the brief window where complexity is possible before the chaos takes over. So master the chaos, understand the math, because the arrow of time waits for no one. We've covered the jiggle of atoms, the ironclad rule of energy, and now the inevitable march of entropy. If you want to keep exploring the deep secrets of our universe, make sure to subscribe to James's Physics 101. Join me for the next lesson, where we'll look at the ideal gas law. I'll see you in the next one.